Hello students, welcome to Anne's classes. Let's do geometry, fundamental concepts, exercise 14a. So we are talking about the fundamental concepts in geometry. State true or false. If false, correct the statement. So we have the first statement here. A dot has width but no length. We're talking about a point. The fundamental concepts in geometry, point, line segment, ray, all these. Okay. So here we are talking about a point or a dot. According to this statement, a dot has width but no length. And as you know, this statement is false. Now, why is this false? It's false because a dot has no width. Here it says it has width, whereas a dot has no width and no length. So this statement is false and we have corrected the statement. Next one. A ray has infinite length only on one side of it. You know what a ray looks like, isn't it? It'll look like this and there is an arrowhead there. So what does that arrowhead indicate? It indicates that that side of the ray goes on continuously, whereas the other end has a fixed point. So here the statement, a ray has infinite length only on one side of it is true. Only on the side which has the arrowhead, the ray has infinite length. On the other side, there is a fixed point. It stops there, doesn't continue there. So this statement is true. Third one, a line segment PQ is written as PQ with, can you see that symbol on top? Okay, now if it is a line segment, we know a line segment has definite length. It will start at one point and end at another point. So this is what the symbol of a line segment will look like, starting at a point and ending at a point. Whereas here, as you can see, there are two arrowheads. Arrowheads will always indicate that it is going on indefinitely on whichever side you have the arrowhead. So this statement is false. That is not how you indicate a line segment. So this statement is false. Let's correct that statement. A line segment PQ is written as PQ with a line on top. Can you see this line on top? So we put a line on top, no arrowheads, because when you have a line like that without arrowheads, it means there is a starting point and an ending point. Next one, PQ with the arrowheads. Can you see the symbol? Represents a straight line. This statement is true because a straight line is the one that goes on both sides indefinitely. So this statement is true. Question 5. 3 points are said to be collinear if they lie in the same plane. Now what are collinear points? They are 3 or more points which lie on a straight line. So this statement is false. Okay, so you can have many points in a plane, but if there are 3 points or 3 or more lying on a same straight line, only then can you say that they are collinear points. So the correct statement is 3 points are said to be collinear if they lie in the same straight line. Next one. 3 or more points all lying in the same line are called collinear points. So this statement is true. Next one, write how many lines can be drawn through all these 1, 2, 3, 4. Now suppose you have 1 point, how many lines can you draw through these? So I can draw many points, many lines like this through that single point. Through one single point, I can draw many lines. So you can either write many or you can write infinite. Infinite means countless, you can't count, unlimited. Next question, how many lines can be drawn through two given fixed points? Suppose you have 2 points, 1 point here and 1 point here. How many lines can you draw through these? You can draw only one line, isn't it? So the answer here is 1. Next question, how many lines can be drawn through 3 collinear points? Remember, we said collinear points are 3 points that lie on the same straight line. So how many lines can you draw through these? You can draw only one line through 3 collinear points. Next question, how many lines can be drawn through 3 non-collinear points? The non-collinear points are points which lie randomly, not on a straight line. Now, through all three here, there are three here. Through all three, how many lines can you draw? You can't draw any. You can't draw one line through all this, isn't it? You can't draw one straight line. So the answer here is none. You can't draw any line through three non-collinear points. Question 3. The shaded region of the given figure shows a plane. So here we have a plane. This is slightly shaded so that you can see these lines clearly. Now, looking at this, we have to name a few things. So let's begin with the first one. Name three collinear points. So collinear points are 3 points that lie on the same straight line, 3 or more. So let's look for 3 points that lie on the same straight line. So here all these are points A, B, C, D. Then we have P here. P is for the plane. Then we have E. So we have so many points here. In that, what are the 3 points that lie on a straight line? A, B and C. So points A, B and C. So let's write that A, B and C are 3 collinear points. 3 non-collinear points. So non-collinear means points that don't lie on the same straight line. So I can say A, D, C, or I can say A, D, B, or A, B, E. I can take any 3 which are not on the same straight line. So let me write down A. I can write A as 1, take D as another point, and I can take C or B or E, any of these as the third one. Then a pair of intersecting lines. Intersecting lines are lines that meet at a point. So here you can see one line and this another line meeting at point D. Now you can see this line and this line meeting at point A. You can also see this line and this line meeting at point C. So let's take any pair of intersecting lines. That means 2 lines. So let me take AC. AC is one line. So let me write that down. So when you name a line, put the letters one next to each other without a comma. So AC. When you're talking about points, it's only one point. That's why I put a comma. Whereas a line will have 2 letters. AC, no comma in between. AC and now this is AC. This whole line is AC with these 2 points. Now what is intersecting with AC here? I can say AD. AD is intersecting. AC and AD are intersecting at point A. I can also say AC and DC are intersecting at point C. Okay, so AC and DC are intersecting at point C. Next one, state whether true or false. Line DE is contained in the given plane. So where is DE? Yes, DE is here. It's inside that plane and that statement is true. The plane as shown here is this figure here, is the shape here which is shaded slightly. So this is the plane and line DE is contained in the plane. It is in the plane. Next one, lines AB and DE intersect at point C. AB, yes, and DE intersect at point C. That statement is also true. Next one. Points D, B and C are collinear. Let's see that. Where is D? D is here, B is here and C are here. C is here. Now as you can see, these 3 points are not on the same straight line. So they are not collinear. So this statement is false. Next one, points D, B and E are collinear. So let's look for the points D, B and E. Are they collinear? Are they lying on the same straight line? No, they are not on the same straight line. So this statement is also false. Question 4. Correct the statement if it is wrong. Okay, so we've been given a few statements here. We have to say whether it's correct or wrong, and if it's wrong, we have to correct the statement. So let's look at the first statement. A ray can be extended infinitely. Infinitely means unlimitedly, continuously on either side. So now if I draw a ray like this, I can see an arrowhead only on one side, isn't it? The other side there is no arrowhead. That means the other side is fixed, whereas the arrowhead will say that that side can be extended infinitely. Whereas the statement here is saying a ray can be extended infinitely on either side. That means on both sides, and that statement is wrong. So that statement is wrong. Let's correct that statement. A ray can be extended infinitely in only one direction. Next statement. A ray has a definite length. Definite length is only if there are two fixed points, whereas a ray has only one fixed point, the other end goes on, so it doesn't have a definite length. So that statement is also wrong. Now let's correct this wrong statement. A ray has indefinite length. So you can't say that the ray has a definite length because the side continues. So there is no end point. So a ray has indefinite length. Third statement, a line segment has a definite length. That's true. Now even this blank here that we have drawn here, this blank is a line segment because there is a beginning point and there is an end point. So there is a definite length. Only a line segment has a definite length. So this statement is true. Now next one, a line has two endpoints. That's wrong. A line will be like this with an arrowhead at that end and an arrowhead at this end. That means it's going continuously on both sides. Both sides can be extended. So it doesn't have endpoints. Whereas the statement is saying a line has two endpoints. This statement is wrong. And let's correct this wrong statement. The correct statement is a line does not have end points. Fifth one, a ray has only one end point. So let's look at the ray. Yes, it has only one end point. So this statement is correct. Okay, so here the third one we wrote true. You can write true or you can write correct. Question 5. State true or false. If false, give the correct statement. A line has a countable number of points in it. Now, if you draw a line, there are many points on it. There are many points on it. So this statement is false because a line has an uncountable number of points in it. So the statement is false. And the correct statement we've already shown. A line has an uncountable number of points in it. Now question 2, only one line can pass through a given point. Now we saw this earlier. Suppose you have one point here, I can draw one line through it, another line, another line. I can draw many lines through this one single point, isn't it? So this statement is also false. What is the correct statement? An unlimited number of lines can be drawn through a given point. Infinite, many. Okay, next one. The third one is the intersection of two planes is a straight line. That's a true statement. That's correct. When you have two planes and they intersect means when they meet, what you get is a straight line between two planes. Question 6. State whether the following pairs of lines or rays appear to be parallel or intersecting. So what are parallel lines? Two lines that will never meet. How much ever you extend them, they will never meet. And what are intersecting lines? Intersecting lines are two lines that will meet at a point. So we've been given four sets of lines here and the pairs are there. We're going to see whether they are parallel or intersecting. So here, first one, we have two lines here. Now, this is one line that's going straight down. This is also going this way. Both ways you can extend. Now, if you extend it downwards, if I have to extend it down like this, they will meet at a point. This line will meet at a point, right? So both these lines will meet at a point. So this pair of lines are called intersecting lines. So this pair of lines is called intersecting lines because they will meet at a point. Let us look at question 2. Here we have two lines. Okay, you can see BC and DE are the names of the two lines. Now, even if I extend them on this side, they will not meet. If I extend them this side below, they will not meet. So two lines that will not meet are called parallel lines. So these are parallel lines. Let's go to the third one. Here also we have two lines. Now if I extend them, the arrowheads are here. If I extend them this side and this side, they will not meet. As you can see, the distance between them is the same throughout. So they will never meet. Such lines are called parallel lines. Fourth one, here I have again a pair of lines. If I have to extend this line like this and extend this line this side, they will meet. Now if I have to extend this line like this and extend this line also like this, can you see they are meeting at a point? And you can see the distance. Can you see the distance here? The distance between these two lines, can you see it's getting smaller and smaller and smaller and they meet. So such lines where the distance changes and when you extend them, they will meet at a point. Such lines are called intersecting lines. Next question. Question 7. Give two examples from your surroundings. That means look around you and then see if you can get two examples for each of the following points. Now we can give the example of the tip of your pen. Look at the tip of your pen, it's a point. The tip of a compass needle, okay, the tip of the compass needle is also a point. So we have two examples here. Now two examples for line segments. The edge of your ruler is a line segment. It has a beginning point and an ending point. So that is the example of a line segment. The edge of a paper, if you take a page of your book, the edge of the page or the paper is a line segment. Plane surfaces are, we're talking about flat surfaces. The surface of the wall is flat. The floor of a room also. These are examples of plane surfaces. Now what are examples of curved surfaces? Examples are the surface of a balloon. It's curved, isn't it? And the surface of an apple, that is also curved. So these are examples from your surroundings. You can think of many more examples for each of these points here. Okay, children, we'll stop with that for now. In our next video, we'll continue with the remaining questions. Thank you, children.